On Chem Tutor. Today we are going to simplify a very important organic chemistry topic. This topic is very common in exams and many students find it confusing, especially when it comes to the different methods involved in preparation of aldehyde and ketones. So this lesson will only focus on one method known as the oxidation of alcohols. Okay, so before we go there, let us first explain, or let us know the meaning of the term oxidation. So we need to know the meaning of the term oxidation. So number one, let us focus on oxidation. Oxidation. So oxidation, or let's say oxidation process. So oxidation can be defined as the addition of oxygen to a compound or a molecule. So oxidation can be defined as the addition of what? Of oxygen. So this involves the addition of oxygen to a molecule. So it's addition of oxygen. Whenever oxygen is being added to a molecule, that is what we call oxidation. Oxidation can also be defined in terms of hydrogen. When defining oxidation process in terms of hydrogen, it is the removal of hydrogen to a molecule or a substance. So whenever we're removing hydrogen from a molecule, that process is known as oxidation. So removal of hydrogen that's what we call oxidation. Okay, this was number one. Number two, let us also define the term reduction process. So reduction is opposite of oxidation. So here on oxidation we said it's addition of oxygen. On reduction we're going to say the removal of oxygen. Removal of oxygen. And at the same time, it can also be defined as the addition of what? Of hydrogen. So this can also be defined as the addition of hydrogen. So whenever we are adding hydrogen to a molecule, that process is called reduction process. Okay, so for oxidation process or oxidation of alcohols to take place, there must be oxidizing agents. These they help oxidation process to take place. So oxidizing agents, we have two types of oxidizing agents. The first one is strong oxidizing agents, and the second one is weak or mild oxidizing agents. So here, oxidizing agents. Let's start first with the strong oxidizing agents. what is the function, or what is the main law of these strong oxidizing agents when it comes to oxidation of what? Of alcohols. So the law of the game here, let me use another ink. Okay, law here. So the rule number one that you need to understand is that strong oxidizing agents converts primary alcohols to carboxylic acids. So these, they convert primary alcohols to carboxylic acids. This is number one. Number two, they also convert secondary alcohols to ketones. So they convert secondary alcohols to ketones. But now we don't know these strong oxidizing agents. So now let us list them. The common strong oxidizing agents. Number one, we have chromium trichloride. So this chromium trichloride is also known as the Jones reagent. So examples here of strong oxidizing agents. Number one, we have Jones reagent. So Jones reagent is nothing but chromium trichloride, which is CrO3. But this is achieved in acidic media. That's why I'll put H+. It is achieved in acidic media. That's why I decided to put H+. So this is what we call Jones reagent. When you just see this, you know that this is a strong oxidizing agent. When it is used to oxidize alcohols, it converts primary alcohols to carboxylic acid, or it converts secondary alcohols to ketones. Number two, potassium permanganate. So potassium permanganate is also a common strong oxidizing agent. So it's KMnO4. It is also used in acidic media, H+, that is potassium permanganate. The third one is potassium dichromate. Potassium dichromate. So Potassium dichromate is K2Cr2O7. It also goes hand in hand with an acid. So those are the common strong oxidizing agents. So let us know how to use this common oxidizing agent. For example, you can be given an alcohol, a primary alcohol like this one, and then how can you convert this primary alcohol to carboxylic acid? Carboxylic acid, it is in this form. From this alcohol to carboxylic acid, what agent or what reagent can you put there? So you just choose, because this is, when you see here, is primary alcohol to carboxylic acid. So automatically this one qualifies to be called complete oxidation process. So we're going to use a strong oxidizing reagent. For example, you can just put your Jones reagent here, form of an acid. Maybe for those of you who don't understand the meaning of primary, secondary, and tertiary alcohols, you may be given an alcohol like this one. How do we identify that this is primary? It is simply because this OH here, the carbon which has OH, contains only one other carbon or one side group like this one. So this has one carbon, qualifies this one to be called what? Secondary. I mean a primary alcohol. You can have also something like this. So if you check, this one is secondary alcohols because this carbon is connected to two other carbon 1 and carbon 2. So this is secondary alcohol. Example number 3. This is tertiary alcohol because it is connected to carbon 1, carbon 2, carbon 3. This alcohol, the carbon which contains alcohol, also has 3 other neighboring carbons, 1, 2, 3. So that's qualified to be called tertiary. So when you're saying primary alcohols, we simply mean this carbon here connected to one carbon, and this qualifies to be called a primary alcohol. All right. Another example. You can also be provided with a secondary alcohol. Example number 2. You can be provided with a secondary alcohol like this one. Then and your product to be ketone. Now remember the law number 2, which explains that this law number 2, strong oxidizing agent converts secondary alcohols to ketones. So now this is our secondary alcohol. This one is our secondary alcohol. So it has been converted to what? To a ketone. Meaning we are going to use a strong oxidizing agent. For example, here let us use KMNO4. KMNO4. Potassium permanganate. This is a strong oxidizing agent. It goes in hand with an acid. or you can just say H plus. Okay. Example number 3. Example 3. So if you check here, this carbon on the center here is connected to 2 carbons, number 1, number 2. So this qualifies to be called what? A secondary alcohol. So remember, strong oxidizing agents convert secondary alcohols to ketone. So this is a ketone. So meaning we're going to also to use a strong oxidizing agent. For example, we can just get from the list there that we have already, this list here for strong oxidizing agent. Just get one. Then that's your answer. These things are very simple. So here you have K2 Cr2 O7 in places of what? Of acid. So that's your final product. So this is how strong oxidizing agents operate. All right, one more example, number 4. What if they have given you a okay, so let us check this. One carbon, this carbon is connected to carbon 1, 2, 3, meaning this is not a primary, this is not a secondary, but is what? A tertiary alcohol. So they can just put sometimes CrO3 H plus. Then they decide to put the answer. So there will be no answer because the tertiary alcohols are unreactive. So these, they don't undergo oxidation. They only undergo oxidation on special cases, but in this case, no reaction. So here, no reaction here. So that's the most important concept that you need to know, that the strong, tertiary alcohols are unreactive. All right, so the other set of oxidizing agents is weak oxidizing agents. So weak oxidizing agents. Okay, now let us also focus on the law so that we should be able to use them correctly. So rule number 1, weak oxidizing agents converts primary alcohols to aldehydes. So these, they do not go completely oxidation process, but they just stop on intermediates. So now the law of the game here is that weak oxidizing agents, they convert primary alcohols to aldehydes. So this, they convert primary alcohols to aldehydes. Okay. Number 2, they also convert secondary alcohols to ketones. They convert secondary alcohols to ketones. So if you check this law, the second law, and this other law here for strong oxidizing agent is one and the same. It is one and the same. So that's it. So weak oxidizing agents convert secondary alcohols to ketones. They also don't oxidize tertiary alcohols because tertiary alcohols are unreactive. So examples of weak oxidizing agents. So number 1, we have our common weak oxidizing agent known as PCC. So when you just see PCC, this is a weak oxidizing reagent. So PCC goes hand in hand with this solvent dichloromethane, CH2Cl2. So PCC goes in hand with the dichloromethane. So sometimes you may be wondering what PCC means. So PCC means pyridinum chlorochromate. So I'll not like that, but it means pyridinum chlorochromate. So number 2, we have DMP. Or this, let me light this one because they sometimes just use the name exactly. So DMP means Des-Martin pyridinane. So this one, it is Des-Martin pyridinane. Okay. So this one is what we call DMP. So these are the 2 common weak oxidizing agents. But if you go further, you also have one of the common weak oxidizing agent known as what? Toluene's reagent. Toluene's reagent. So Toluene reagent is not common though, but it is AgNH3 plus 2 plus. But in this case, we are going to be using this one, the mute, PCC, and the DMP. So these are the ones that we are going to be familiar with. All right. Now let us okay, before going to examples, You have to understand or know by heart that weak oxidizing agents, they are selective, meaning they are stopping at intermediate stage instead of full oxidation. Let us take note that one, not here. Not weak oxidizing agents are selective. These are selective, meaning they stop intermediate stage instead of full oxidation process. Instead of full oxidation. Okay, so you need to know this, that weak oxidizing agents, they just stop at the intermediate stage. We can now dive into examples. Let's get the same example like the first one there on strong oxidizing agent. Here let's get OH, this compound here. If your answer is an aldehyde, because this is a primary alcohol converted to what? To an aldehyde, meaning we're going to use a weak oxidizing agent. So here your answer is PCC in dichloromethane. Simple, straightforward, because you are converting a primary alcohols to an aldehyde, not to a carboxylic acid. If this here was a carboxylic acid, we would have used a strong oxidizing agent. Number 2. Okay. So this is a secondary alcohol, and this is a ketone. So also weak oxidizing agents convert secondary alcohols to ketones, same as the strong oxidizing agent. So here you can have any choice. If you want, you can get a strong. If you want, you can get a weak oxidizing agent. There's no problem. So here I will just get dense Martin Widnan DMP. It will give us that product. Number 3. Let me get this one. So this is also a secondary alcohol converted to a ketone. So you can also use a weak oxidizing agent, PCC, in dichloromethane. Okay, one last example. Let us have this structure on the middle here. And the product here. So you can start providing answers there using the examples that we have discussed above. So here, product is this one. So you can just use different agents to form these products. Okay, and the last one, almost the same. Okay, so now you can fuse the answers. Let us fuse the answers together. So let us first check what kind of alcohol is this one. So this one has only one what? The alcohol, the carbon which has an alcohol here has another carbon there. That's it, carbon. So this one qualifies to be called a primary alcohol. So number one, this arrow here is showing that this primary alcohol has been converted to an aldehyde. So meaning this is not fully oxidation process. It is selective because it is stopping at the intermediate instead of a completely oxidation process. So I'm going to use your weak oxidizing agent. So here you can use PCC in this solvent chloromethane. Number two, this one down here. This structure is same as this one. So meaning a primary alcohol has been converted to a ketone. Also, we are going to use what? A weak oxidizing agent, DMP. Okay, but if you check here now, this primary alcohol has been converted to a carboxylic acid. So this is full oxidation process. So meaning we're going to use a strong oxidizing agent. So you just pick one of the strong oxidizing agent. For example,